Hello everyone. Today we are here to perform the experiment known as the flywheel. The aim of this experiment is to determine the moment of inertia of the flywheel and hence calculate its mass and density. The principle is the angular acceleration of a flywheel depends on the torque acting on it. The torque is applied by means of a known mass to produce the angular acceleration. By measuring the angular acceleration, the moment of inertia I is determined. Mass F is applied on the flywheel. The torque starts acting on the flywheel and starts the angular acceleration of the flywheel. This angular acceleration can be measured and later used to determine the moment of inertia of this flywheel.
The apparatus required to do the following experiments are a flywheel, weights, a vernier caliper, a stop clock, a long wooden scale, a piece of thread.
The parts of the flywheel consist of the main flywheel, the axle and the scale pan. The formula used in the experiment are the formula used to calculate the moment of inertia of the flywheel I is equal to m2 minus m1 into gr divided by alpha 2 minus alpha 1. The alpha 2 and alpha 1 are the angular accelerations respectively to mass 2 and mass 1, and g is the acceleration due to gravity and r is the radius of the axle. Here. Next, we use the formula to calculate the mass of the flywheel m, which can be calculated using 2 times moment of inertia of the flywheel divided by the square of radius of the flywheel. Next, we use the formula to find the density of the material of the flywheel, which can be calculated using m, which is the mass of the flywheel, divided by pi into r square into d, where r is the radius of the flywheel and d the thickness of the flywheel. Perform the experiment. First, let's write down all the values of MSD and the least count of the vernier caliper that we are using. Vernier caliper to measure the radius of this axle of this flywheel. We do this for 3 trials and find the radius of the flywheel, and then we take the mean of those 3 radiuses. We use the vernier caliper to measure the thickness of the flywheel. Try it for 3 times and find the thickness of the flywheel and then take the mean of it. Use this string to find the circumference of the flywheel like this, and then we measure this string to find the circumference of this flywheel. Use the circumference to find the radius of the flywheel, and then we note down all those 3. Perform this experiment by giving a known mass m on the scale pan and then note down the time taken for each of the 4 rotations, 6 rotations and 8 rotations of the flywheel. After noting down the time taken for each 4 rotations, 6 rotation and 8 rotation, and do it 3 times and find the mean t, and we repeat the same procedure for 100 grams, 150 grams and 200 grams, and then we use these values to calculate the alpha for each case and take the mean of the alphas. Then we find the momentum of inertia for 3 different combination of masses. First m1 and m2, m1 and m3, and then finally m2 and m3, and then find the mean moment of inertia for the flywheel. Then we use the momentum of inertia to find the mass of the flywheel and the density of the material of the flywheel by using the formulas mentioned before. After finding the mass of the flywheel and density of the flywheel, we note down the results, which is the moment of inertia of the flywheel, mass of the flywheel and density of the flywheel, and with this we have concluded our experiment.